Here's a riddle. A student enters 2 plus 2 into a calculator. The answer is 5. The calculator is perfectly well functioning. So, why then? Any guesses? The answer is right above you. Well, way above you. It's the sun. Yes, solar rays can and do mess up calculations like these, including far more consequential ones in laptops, phones, and satellites. The reason traces back to the underlying semiconductors, the silicon chips that encode digital information as zeros and ones in these devices. On rare occasions, a rogue solar ray can strike the silicon in just the right way and flip the 0 or 1 switch. This phenomenon is called the cosmic ray bit flip, which honestly would make a great name for a disco move. Anyway, try that for an excuse sometime. The sun bit flipped my homework. Here, we're interested in a very similar phenomenon, but for an entirely different purpose: solar power. The modern solar panel is all about getting the sun to strike silicon semiconductors in a much more productive way, so that excited electrons translate into usable electricity. And ideally, a lot of it. Solar power is infinitely renewable and astonishingly abundant. Every 2 minutes, we receive enough solar energy to power the planet for an entire year. The challenge, of course, is harnessing it. We're doing a lot of harnessing already. Today, global solar capacity is now approaching 2,000 gigawatts, enough to power nearly 200 New York cities on a summer afternoon. Still, all this solar power accounts for just 2 to 3% of total global energy needs. Why? Well, building out solar capacity takes time. Plus, while abundant and infinite, solar power is certainly not a perfect solution. For one, it's intermittent. Clouds, nighttime, both literal solar buzzkills. Solar is also less space efficient than alternative power sources. It takes a lot of land mass. To power the entire U.S., for example, some estimates suggest we'd need 10,000 square miles worth of solar, about the size of Massachusetts. Nonetheless, many see a bright future for solar power. It's growing fast. Installed solar capacity has been doubling every 3 to 4 years. Some predict it could become our largest source of energy globally by 2040, and they have good reason to be bullish. Solar is already very low cost to produce, and costs continue to fall as the technology improves. Plus, it's relatively fast to deploy. A new site can go from planning to operational in under a year. Wind projects can take 2 to 3 times that long. It's also highly distributable. Solar panels can fit just about anywhere. Distributed solar systems, like rooftop panels, are helping us mitigate the growing demands on the power grid by generating electricity closer to the point of consumption. In this primer, we'll explore this dynamic industry, shining some light on how solar technology works, what makes solar power plant projects unique from other power projects, the economics of solar plants, and the key trends.